We're going to venture into more complicated factoring of trinomials. If we haven't watched the previous videos, we should, and we should conquer that before we come here. But remember, our goal is to take this trinomial and change that linear term into the sum of two other linear terms. And the b sub 1 plus b sub 2 is going to have to equal that guy, and the product is going to have to be equal to a times c. So here's what we got. A is 2, c is 15. 2 times 15 is 30, sorry. So the b sub 1 times b sub 2 is going to have to be 30, but the two linear coefficients are going to have to add up to be 11. So let's think of two factors of 30 and see which ones will add up to 11. These are combinations of factors of 30, and there's only one, these guys, that add up to 11. So those are our targets. That's b sub 1 and b sub 2. So we're going to rewrite this guy. We're going to say, okay, we got the 2x squared plus the 5x plus the 6x plus the 15. So b sub 1 and b sub 2 right there. Now, divide and conquer. So we're going to take the greatest common factor out of these two guys, which is going to be x. What's left is 2x plus 5. Going to go over here. What's the greatest common factor? It is 3. So we're going to add 3, and what's left is 2x plus 5, which is spiffy because we have the same binomial. So in the end, how many of the 2x plus 3's do we have? Well, we have x of them, how many of the x plus 5's do we have? We have x of them here and 3 of them here. So altogether we have x plus 3 of the 2x plus 5's. If we go to another one, we got this guy here. It's a little bit trickier now. We need two linear coefficients that add to a negative 11, but they multiply to a times c, which is 24. Well, when two numbers multiply to a positive, but they add to a negative, both those values are going to be negative. So, which of these multipliers, these factors of 24, will also add to negative 11? Answer, these puppies right here. So, we're going to rewrite this trinomial. We're going to leave the quadratic term alone. We're going to leave the constant term alone. And we're going to replace this linear term with the sum of two linear terms, negative 3x minus 8x plus 12. Now we divide and conquer. We go to these two guys right here. The greatest common factor is just going to be an x, and we're left with 2x minus 3. We go over here, and the greatest common factor, we're either going to say it's 4 or negative 4, and let's think this through. Our goal over here is to end up with the exact same binomial that we have right there. So for that reason, let's factor out the negative 4. So make this a minus 4, and there we go. This is equivalent to that. So in the end, how many of the 2x minus 3's do we have? We have x of them here, minus 4 of them there. So altogether we have an x minus 4 times 2x minus 3. Done. We've factored that trinomial. Now, why does it work? It's a little complicated. Let me just kind of head us in the right direction. The reason we need this combination that adds to negative 11 and multiplies to 24 is because in the end, when you end up with your binomial, you're going to have 4 coefficients. A 1, a negative 4, a 2, and a negative 3. And in the end, for example, for us to get this negative 8x here, we're going to need a negative 4 times a negative 2. That gives us a negative 8. That's a negative 8 right there. For us to get the negative 3, we're going to have this negative 3 get multiplied by this x to give us a negative 3x. But meanwhile, we do need a 2 as far as our quadratic term, so we need a 2 in front of one of the x's and a 1 in front of the other x, so that 2x times x is 2x squared. So in the end, we really need these coefficients to be able to multiply to give us these guys right here. The negative 4 times the 2 is going to give us a negative 8. The negative 3 times the 1 is going to give us a negative 3. We have to utilize the factors within these factors to be able to have everything come out right. If that makes sense, awesome. If not, who cares? All you got to do is follow that rule that seems to be working just fine for us. Let's do a couple more. So we got this here. All right, once again, we have now our coefficient for the linear term is a 1. So we need two linear coefficients that add up to 1, but they multiply to 12 times negative 6, which is negative 72. All right, we need two numbers that multiply to a negative, but they add to a positive. One's got to be positive, one's got to be negative. The bigger number needs to be positive because when we add them, we get a 1. Now we could go to the trouble of listing all the possible factors that multiply together to give us negative 72, where the smaller one is negative and the bigger one is positive. But I think there's a quicker approach. The absolute value of these guys only differ by 1. So which pair of these guys differ by 1? It's this one. So you go try two factors that are pretty close to each other. It's like, oh, the two numbers that multiply to a negative 72 but add a positive 1, these puppies right here. Now remember, we'd like to replace this linear term with the negative one. It just makes it easier for us to factor. So we're going to multiply, we're going to have 12x squared. We're going to leave the linear term alone also. And now we're going to replace this linear, leave the constant term alone, leave the quadratic term alone. We're going to replace the linear term with these two guys. We're going to have two linear terms. One is going to be a negative 8x, the other one's going to be a positive 9x. So this is equivalent to that. Now divide and conquer. What do these guys factor into? Greatest common factor is a 4x. What's left is a 3x minus 2. All right, then we go over here. Greatest common factor is a 3. What's left is a 3x minus 2. So in the end, how many of these 3x minus 2's do we have? Well, we have 4x of them here, and we have another 3 of them there. So in the end, we have 4x plus 3 of these 3x minus 2's. There, we factored it. Life is good. Last problem. Holy smokes, look at that. We need two numbers that add to 125 and multiply together to give us 3,750. I don't think so. There's a shortcut that we need to take here. Really, this is the first thing we should do. I just wanted to make sure we had the basics down. But before you start factoring by grouping, is there a common factor you could take out of here? And the answer is yes. They all have a 25 in it. So you can make this 25 times 3x squared plus 5x minus 2, and then we take it from there. Don't forget that the 25 is here, but now let's work on this puppy right here. We want to rewrite this and replace the middle term of 5x with two coefficients that add to 5 but multiply to a negative 6. So what we're going to do is that's going to be a plus 6x minus an x, and then we still have the 3x squared, the minus 2 inside the parentheses, and do not forget that this 25 is out here waiting for us. So do the same old thing, divide and conquer. Let's bring the 25 down so we don't forget it. These two guys, the common factor here is going to be a 3x. So this is going to become a 3x times x plus 2. We go factor these two puppies out here. Let's take out a negative 1. So this is minus 1 times an x plus 2. And how many of these x plus 2's do we have? Well, we have 3x of them here minus another one there. So we have 3x minus one of those guys, but do not forget that on the outside you still have the 25 waiting. So there'd be factor, factor, and another factor. There you go. Now go practice. You need to have enough practice to where all this stuff becomes automatic.